Cool. Why don't we just kick it off, Mickey?
Sounds good. Hey, everyone. So I know y'all's got a little bit of the chatter that we were talking about. I just came back from Miami yesterday, spent an entire day flying. Would highly not recommend it. Yeah, but it's still going to be an exciting hour. So we have a few exciting hosts that are going to be joining us from Redis, and we'll be covering a couple things. So Sima, do you want to go to the next slide? Okay, awesome. So our goals today is, number one, define what a feature store really is in practice. I know lots of you have probably heard the term feature store. I know some of you might have an impression of what it is based off of maybe some initial interactions with feature stores. Maybe you've tried setting one up yourself. So we're going to break it down, not just the implementation of it, but conceptually what a feature store is and what it should do. The next thing we're going to cover is how to choose your platform when working with a virtual feature store. We would have defined it earlier, so you know what a virtual feature store is, and we're going to just kind of give you some tips. The third, of course, is we're going to show you real code on how feature form would work on Azure, Redis Enterprise, and Databricks. We know that is a very, very popular stack for everyone out there. So we're excited to kind of show you like a real demonstration, a real example that you can, grit your teeth into. Okay, so the agenda, we're going to cover the feature engineering process for people who are new or maybe are more on the software engineering side, or you're an ML Eng, ML Ops team. The virtual feature store architecture. We're going to show you how to choose your data infrastructure to power your virtual feature store. What is the right underlying stack that works, that's going to work for you. We're going to do a demo narrated by yours truly. Think of it as I introduce you to the wilds of machine learning with features. A little bit of David Attenborough, but with a short Asian chick. And then the last thing we're going to do is how feature stores are used from single data scientists to enterprises. We're really excited, of course, to have some fine gent from Redis who, combined with Simba, will maybe talk about some horror stories, of course, not naming any specific customers. Next slide. Okay, who are we? Let me go left to right in the middle. So first, we're going to have Simba. Simba is the founder and CEO of Featureform. Prior to Featureform, Simba had founded a company called Triton. It was a media personalization platform, handled at 100 million active users. Through Triton and through working with customers, and Simba can talk about this a lot more as well. But he found that like feature engineering was really the part where teams are really struggling. A lot of those experiences working with customers helped found that the basis for Featureform. Next, we have Sam. Sam is a principal applied ML engineer. Title from Redis. So Sam has experience working with high performance computing. So really excited to hear, especially about, for example, what is a customer's experience with serving features in performance, right, with high latency. That'll be really, really exciting. You might know me as a personality on LinkedIn. Maybe you have attended my live streams. You've seen me wake up in my PJs. You've seen a side of me that, frankly, a lot of professional people probably shouldn't, if I were to be really honest. But I'm the head of MLOps at Featureform. Feel free to ask me outside the webinar what that actually means. But the part that is really exciting is I get to take my experiences working on the ML platform team at MailChimp. You might have heard of that company, email marketing company acquired for $12 billion by Intuit. Prior to that, I worked at different companies like Autodesk, Teladoc, if everyone remembers the telemedicine, trend during quarantine. But yeah, so that's me. I've done a lot with data science, and ML. Cool. Okay, so features. I think we all know what features are, but let's just reiterate. Okay, so they're inputs into models. What does that mean? That means, for example, if you go into Spotify and maybe it's been a very slow day and you need your lo-fi morning pick-me-up chill jams playlist, how's Spotify making that recommendation for you? Well, they're looking at things, for example, like time of day. What are other users around you listening to? Like maybe in your geo, maybe in your time zone. They're looking at, how many times have you hit the hip hop 90s jams focused playlist? They're looking at the songs you've listened to. All these are features that can be fed into a model. Most models are going to have multiple features. And you might even, for example, have features used between different models. Features ultimately are, if with labels, for example, they will ultimately form data sets, which ideally you would use to then train a model and then put into production. We're talking about supervised learning, but there are other examples, right, where you can still use features even in non-supervised learning examples. Okay, so we all know feature engineering, it is the art and science of machine learning. That is where you're going to get the most bang for your buck. Now, what happens in feature engineering? You start with a bunch of different data sources. Ideally, you take that raw data, you then transform it, aggregate it, you then create these features. Ideally, they will be documented, they'll be cleaned up. You'll use them in combination. You might do some feature selections, and then you'll feed them into a model, which will then use to predict, say, for example, the next song that someone is going to want to listen to in their Spotify playlist. And you have a label that will ultimately be your baseline and your source of truth to compare back against. Okay, so the data scientist workflow. Feel free to raise your hands or put into chat if you have ever copy pasted, and it's okay, be honest here, people. If you have copy pasted Jupyter Notebook code, if you've copy pasted Python scripts, if you've copy pasted Bash shell scripts, even raise your hand if maybe, for example, I don't know, your team has put together a weird Frankenstein cookie cutter deal that you ran off a command line and then it would break sometimes. Who knows, maybe they'd fix it. So feel free to, drop in chat, raise your hands if all that has ever happened. So the data scientist workflow. You have ideally a group of data scientists. If you're a solo data scientist in an early stage startup, good luck. Godspeed. But let's say you're in a team, a lot of different projects are going on, a lot of different notebooks, a lot of mess to get from data to eventually model. I mean, so that whole data-centric AI, there's a lot of assumptions there. Ideally, everyone wants to get there, but do they actually? I don't know. What does the next slide look like? Oh, dang. And that is everyone's reality. Oof. Messy. I know, right? And it's not like this got better after people learned how to use Git. Who else used the missing CS semester, Git lecture? And like Pro Git. Those were my two jams. I'd like to say I got a lot better after that, but nevertheless, everyone understands that versioning data is hard, versioning tables is hard, versioning notebook sucks. So you still kind of end up getting this. Yeah, messy. Just
yeah. What I've seen is there's so many different. You have your features, you have your transformations, you have your kind of the whole components of what makes a feature up. And it's your job as a data scientist to not only be working in your notebooks, coming up with ideas for new features, and also like interacting with Databricks, Redis, Lobster yourself to try to get this in production. You don't really have a way to version and manage the resources, the transformations themselves, the features themselves. You can maybe version the notebooks, you can maybe version the data sets, but the actual resources you're creating underneath, it's all ad hoc. And that's where a lot of the copy and pasting comes up. That's where like the Google Doc full of SQL snippets comes up. But let's talk about what a feature really is. What does it really look like? It's kind of scattered across a lot of different places. It starts with your data source. Your data source could be a string, it could be a table, it could be a file. And when you're taking Coursera classes, that's it. Like you're done. Like the columns and features are perfect. In reality, that's not what happens. There's essentially a whole DAG of transformations you're going to create. It could be SQL, it could be Spark code, could be a lot of different things that you'll use to take that raw data and turn it into the final features that you're going to use. Then you need it in for two modes. One mode is for inference. So if you have a model in production, or in general, you just have a model, you need to get the current values of features to make predictions. So again, the Spotify example, like you need to know the values of the features for your recommendation model in real time to be able to make a recommendation. Now, models aren't just using inference, they must be trained. And so not only do you need the current values of features, you also need to know the historical values of features so that you can look at a label, figure out what the features were at that point in time to actually train your model. So again, it's your job as a data scientist to take the data source, transform it, get it into the inference store, get it into the training store, keep all that organized. And as you're working as a team and you have multiple people working on similar DAGs, kind of make sure that you're all working together and don't break each other. Now, this stuff actually lives somewhere, right? So in this example, in the demo we'll be working with Blob Store, Databricks, Redis, and we'll be creating training sets in inference and serving features for inference as well. So this is what your job is as a data scientist, is to interact with all these things, get them to where they need to be, work in your notebooks, and come up with features. Once you have something useful, you switch to maybe some YAML files, some bash scripts, something to try to get all this stuff in the right mode. Now, there's two sets of problems here. One set of problems is what we would call the ops problem, which is much more about scaling teams, scaling people, just keeping kind of having a workflow. It's almost like the workflow problem of building features and iterating on features. The other set of problems we call the platform problems. The platform problems are things like the latency. I'll actually kind of get into this. Like I said, like some of the ops problems are: who owns this feature? How is it defined? Am I allowed to use it? Which models are using it? Who built this feature and maintains it? How do I serve this feature in production? Like how do I actually get the data fraud? So these are the ops problems. This is like a whole set of problems that exist here, like versioning, management, governance, all that falls under the ops umbrella. The other set of problems is what we call the platform problems, which are things like how fresh is this feature? What's the latency to serve it? If you have a real-time model, which Sam will get into, like that becomes top of mind. The feature's SLA. Like in the end, like sometimes features go down, sometimes databases, they're not always up, unfortunately. So understanding the SLA becomes really important. Understanding if you can handle streaming data is important. And if you're dealing with like more complex data types like embeddings, you might need to have a platform that can do nearest neighbor lookups. So all this stuff would fall under the platform problem. This is the stuff that kind of is solved by the infrastructure. The idea of the virtual feature store. The concept is, what would happen if we built what we call the feature store abstraction and applied on top of the infrastructure? So we'll, you continue using the same infrastructure you're using, or pick the right infrastructure for your use case. And we'll provide governance, monitoring, or search and discovery, a unified API to define features, to manage them, version them, set up governance, one API to be able to serve the features on the other end. So it becomes this kind of framework and workflow tool on top of the existing infrastructure. Why that's useful is you get the best-in-class platform. So you can pick and choose, like in this case, like we're going to be working with Redis, Azure, and Databricks, while having feature form take this kind of the raw power of all of these platforms and build this feature store workflow on top of it. That's the virtual feature store concept. And why does that work? Well, there's two things here. One is low adoption cost. If you're looking at a feature store, you likely don't want to rip out and replace things like Spark and Redis. Like those tools are amazing. You don't want, you want to continue using them. You don't want to have to rewrite your features. You don't want to have this new big heavy piece of infrastructure that you're kind of tied to, stuck on. The virtual feature store is more of an orchestrator and metadata management. So it works with your data infrastructure, again, providing that framework and workflow, the virtual feature store abstraction on top of the infrastructure. Second, you can choose the right infrastructure for your needs. And where that gets really interesting is with some of our users, we have certain teams that use Spark and certain teams that use Snowflake, or there's different online stores being used in different places. And you can pick and choose what you need. You kind of separate that problem out. So I'll hand it over to Sam to talk about how to think about. So this is the ops problem. I'll hand it over to Sam to talk about the platform problem.
Yeah, thanks, Emma. So as was mentioned before, I have a super long title, which basically just means that I implement things for customers. And specifically, I implement Redis in the context of machine learning pipelines for our customers. So part of that is also just education on when you may need a fast feature store, specifically one called an online feature store. I'll get into the difference between online and offline. But first, I just want to say that I'm going to cover two specific buckets that we've been working in. The first is Redis as a feature store. As was mentioned, that is one of the platform options that Sim was talking about earlier. And then also, he mentioned those nearest neighbor lookups for things like embeddings. Well, I'll also talk about how Redis is being used as a vector database for those nearest neighbor lookups in that context. Next slide. So yeah, there's a difference here between your online feature store and your offline feature store. And this is something that Featureform is going to orchestrate for you. So you have all these real-time sources. They may be streams. You may have batch data sources like a data lake coming from either Databricks or Azure. And you need to bring those together and then serve them at a low latency. When that latency becomes at a certain threshold, say below 10 millisecond latency, you need an online feature store. Specifically because if you were to serve features straight from something like a data lake or even something fast, comparatively like a Snowflake, you're still going to be in the 100, 200 millisecond range. If your service has to, for every request that a user may generate recommendations, if it has to then go and pull those features from a 200, 300 millisecond store in terms of latency, that service will end up being very slow when under load. This is where an online feature store comes in. Platforms like Featureform will orchestrate how your features go from those data lakes, those offline stores, into your online stores through processing like Spark or streaming. And that will be your materialization schedule. A large part of what I do is actually setting up materialization schedules for people from their offline store like a Snowflake or an Azure or a Databricks into an online store like Redis. Next slide, please. So this on the left-hand side shows you a little bit of an example of Featureform orchestrating something from maybe it's Delta Lake or one of those Azure blob stores that was mentioned earlier, and then materializing features into Redis. The important part actually of the inference pipeline, which you see there on the top, which is actually serving these requests to your users, is that retrieval of online features. And the important part to note there is that that is usually going to be in a single digit, even sub millisecond latency for your feature retrieval. It depends on your features, but the table on the right will compare Redis to a number of different online stores and show you that these latencies really matter when you go to production, because if you're expecting something to be real time or even near real time, every one of those feature retrievals that your user, when they click on the button to generate recommendations or they refresh their feed, they expect that new feed to be generated as soon as possible. And if your algorithm is the one generating those recommendations, then your feature retrieval is just as important as your inference. Likewise, Featureform will also orchestrate the training portion. But as you can note, you don't necessarily need an online store for your training portion because you can afford in your training pipeline a large amount of latency for retrieving those features. Now, I'll talk about a couple different contexts here in which you may be choosing different facets of an online store. So in one case, you may be saying, well, storing everything in memory is going to be really expensive, and I need to materialize terabytes of features. because I still need them at a low latency, but I need large amounts of features at any given time. Well, this is where databases like Redis have features like Redis on Flash, which will actually store them in things like SSD, which will give you a sort of middle ground where ops per second won't be as good, but costs will go down significantly. And that gives you a sort of ability to tailor, given the percentage that's on Flash and the percentage that's in RAM, how much things are going to cost versus how many ops per second you're going to get. And with stores like Redis, you'll be able to kind of tune that ratio to exactly what your service needs. There are some people that run all in RAM and at massive scale because they have to have the freshest features as fast as possible. There are some people that run 1 shard per node and all they do is write almost everything to a 2 terabyte NVMe drive. This kind of trade-off is what the online store provides in flexibility. And so those are some different settings in which you might choose. Another one is high availability. Can the service go down? What is the uptime of this service? What is the effect if this service goes down? And so you may want to consider things like replication. And if you have replication, keep in mind that this doubles the amount of data in your online store. Every time you create a write, you're also writing to a replica. And so you'll have 2 sets of the exact same data. Now, this will create a highly available situation where if one node in your cluster goes down, you will immediately have a backup, but it does increase your costs because the size of the data is now doubled. So there's a lot of different factors to consider, but that is how we kind of usually walk through what an online store is. Lastly, next slide, please. So another thing here is, and you can just click again so that the database comes up. Yep. Another thing here is that what we've been doing with Redis recently is we've had a number of people ask for being able to store, index, and search embeddings inside of Redis. So what does this mean? Redis is an unstructured data store to some degree. It is not like MySQL, okay? So it's not relational. But in the past, it's really been, string data primarily. And one new data type that we've added is a vector so that you can take things like audio data, text data, video data, what have you, and then feed those through models like transformers, and then push those into Redis, which Redis search will create you an index that you can then search, do k-nearest neighbor lookups. We have a couple different indexing algorithms. And what that'll allow you to do is do embedding lookup at the latency of an online store. So in addition to all of the normal feature storage things that Featureform can orchestrate for you and put into Redis, you can then also do your k-nearest neighbor lookups from that same online store, providing you the ability to create some really cool recommendation systems. If you want to see some examples, you can go to ecommerce.redisventures.com or docsearch.redisventures.com. A couple different cool examples. One searches through archive papers for you. One shows you cool fashion products. But either way, just showing you how these embeddings work in practice. Lastly, we also just did a hackathon on vector search. So if you want to see even more cool examples done by people like you can check out the whole list of those examples submitted on our GitHub. And I'm sure there'll be a link put somewhere on LinkedIn if you just stalk me enough. So thanks.
Awesome. Great. Well, we're about to set up the demo that Makiko will give. I'll stop for a second if anyone has any Q&A. There's a question. It's just trying to understand why online feature store is required. Can we directly use the model file, like TensorFlow model for inference? So this is for the features. So if you're, let's say, making a prediction, if you're Spotify, you want to recommend a song to a user, you need to know maybe the top song they've listened to this week, their favorite genre of all time, like top playlist today. Those are all features. That stuff does not live in the model. Those features have to be generated and created, and they will want to be materialized in something like Redis for low latency lookup. And then Sam, feel free to take over if I missed any.
One of my favorite examples of this is the credit scoring because of HIPAA data, like personal data. Think about that. So even if you're on your website and you're filling out a form, and that form has every field known to mankind, there's still probably some field that you have to get from your database because of some type of regulation. there's always going to be more data in your database on a given customer or on a given person than there will be at the side of the request. So really what online feature stores do is enrich the data prior to going into a machine learning model. So that's, and doing that obviously very quickly at a low latency. But that step's usually required for most machine learning models today.
Great. We'll give a second for any of our questions. Mickey, I'm going to make you host so that you can share. Feel free at any time to ask questions. Like there'll be natural breaks throughout the presentation that we can answer them. How often you get this much of a crew to answer your questions directly?
Awesome, great. Okay, so everyone can hear and see screen. This is great. Okay, awesome. And it looks like we have another question. Simba, Sam, do you want to answer it now, or should we go into the demo and then grab it at the end?
Let's see. How can I know? Let me type out an answer and then we can circle back at the end.
Okay. Awesome. Fantastic. Okay. So like we said, we would show all of y'all's a real code example, something meaty that you can, sink your teeth into and maybe even visit the Featureform docs and give it a try or swirl if you'd like. Okay, so let us centralize onto the concepts that we're talking about, right? So I'm just showing you the Featureform UI, but specifically, let me call out some components. We had mentioned the importance of providers, of choosing the right provider. And for anyone who's wondering, there's a reason why this is empty, because we're going to fill it together. You have your models. For your models, you need features, labels. And ideally, for most data scientists, we're thinking about training sets. Okay, so these are all like core components of training and deploying machine learning models at scale, right? So we've kind of talked about this transformation. And just to, we can show you guys these first couple code blocks. We don't really, it's just a setup for the Colab notebook that we're going to be running and installing Featureform. But let's just talk about how are we gonna flow through this? So we talked about the importance of data sources, transformations, the offline store and the online inference store. And that's how we're going to do all this definition. So we're going to essentially define these different kind of components. We're going to register them with Featureform. When we say register, it's basically make Featureform aware of all these components. And then we'll run it, we'll apply all of this. And then we'll show you how you can actually fetch the features to train a model. In this demo, we are using a real commercial data set of about 100K orders. If you're interested, you can check out the Brazilian e-commerce data set from Kaggle. And ideally, this should kind of mimic everyone's everyday life working as a data scientist. And of course, we mentioned we'll be using Azure Blob Storage with Databricks, and we'll be using Redis as our inference store. Okay, and once again, feel free to plop questions at any point in time. So the first step, of course, is registering your providers. Specifically, this means giving configuration information to connect to Blob Store, Databricks, Spark, and Redis. And a lot of this stuff actually is really kind of a one-time thing. Once you essentially set up the configuration for your project, you'll then be able to create the transformations, fetch it, all that great stuff. Now, as we mentioned, the offline store, that's where you're going to store your data sets. It's where it's going to store the transformations. It's going to store the training set. And then your inference store, Redis, is where you're going to essentially fetch to really take advantage of that high latency. Right. And of course, I should run this as well. Sorry, I just get so excited talking about this. Okay, so the second part, we mentioned this is a real commercial data set, which means there are a couple different core components. You might come into a data set already knowing the kinds of questions you want to ask. Maybe you're coming in with a real business need. But maybe, for example, you actually see like a very interesting data set. You're a new data scientist in a new company or new product, and you want to do more of a, a search. You want to generate questions out of that. So in this case, this means registering your primary data source. So feature form, we can handle tables, we can handle files. We're really meant to help plug and play into your underlying infrastructure to essentially kind of smooth out a lot of the inefficiencies that typically come up from having to hopscotch, your data store provider, your training environment. We're really trying to bridge and create the abstraction that makes a lot of this process more seamless. So I'm going to go ahead and run these. And I'm just going to talk about what is all this information that we have here, right? So I think all of you can quickly see, okay, we know we're using Spark. We know we're registering a file. We've got a payments, orders, customers, reviews data set that actually includes text data. But what about all this other stuff? Okay, well, a very, very common pain point, at least it was for me when I was working as a data scientist and then an MLOps engineer, was figuring out the metadata, was figuring out the context around which tables or sources or features were generated, was figuring out like who was the last person who had touched it and why, right? So a very common pattern with feature form is essentially we give you all these opportunities to bundle the documentation with the logic, with the code, with the data. And that's what you'll see here. For example, you can name it. We have a variant, which you can think of as version. You can do default. You can do, sorry, I was about to say, Kristen's forecasting model, 2020 or something. You can do different variants because features are immutable and they are a first-class citizen in feature form. Features will never, ever be overwritten. We will store all those versions, and you will also have the description. This is very key. I mean, who here has looked at a SQL query or something, and you were like, wow, I really wish there was some comments about it the way you can sometimes get in dbeaver. Apparently that was a thing, right? So this is what we provide you. Okay, so we've done two things. We've registered the provider. And once again, you can plug and play your own provider. We're not going to dictate that for you. We figured that you know your infrastructure best. The second part was we registered the data source. Okay, now we start getting into the real meat of it, which is registering our transformations. Now, there are two types of transformations that we can support: SQL and or data frames. It depends on the provider. I'm just going to show you some quick examples of it. It looks like there is also a question from Kevin. Simba, do you want to grab that, or should I do that right now?
Sorry. Yeah, I got it. Is materialization or synchronization needed in offline and online store, depending on refreshness requirements? How does that happen under the hood? That's a really good question. So the answer is yes. Like features in an online store, typically you want it to be, again, there's a question of how fresh do your features have to be, right? In some use cases, like credit scoring, fraud detection, it might be as immediate as possible. It needs to be a streaming feature. In some use cases, maybe a 24-hour window is fine. So this is, again, where choosing the right platform for your needs makes sense. If you're doing fraud detection or credit scoring, you almost sure they're going to want something like Redis for the online piece. In terms of the materialization itself, so without feature form, that would be your job, right? You would go and build a feature, you create kind of almost like a materialization of the current values, and then you would copy that to Redis. Now, with feature form, which as Makiko will show soon, you don't actually need to do that. You just automatically will do it for you. How does it happen under the hood? Well, feature form runs, it's Kubernetes native. So with certain copies, copying from a Snowflake materialization to Redis for a batch materialization, the way feature form will do it is it will run a Kubernetes job. So we'll spin up a ton of pods and just kind of copy them in chunks over to Redis. That's one way. For streaming features, you can actually push kind of current values to Redis while appending rows to the training data, which is another use case. So it depends on if it's streaming or not. But in general, feature form will handle it, and feature form will try to be as optimal as possible in getting your most recent values into the online store and keeping historical values in the offline store.
Awesome, cool. Absolutely fantastic question, Kevin. Thank you very much for that. Yeah, so as Simba mentioned, we're essentially going to perform basically as honestly as well as your underlying provider. Now, what we do try to provide a common interface, right? And you'll kind of see this actually with the example of different transformations that we're just going to walk through. So I mentioned that we support two of them, right? SQL and data frames. Our goal is always to not add more complexity to a data scientist kind of like day-to-day worldview, because they're already dealing with so much. I know I was as a data scientist, right? And so there's a couple of transformations that you could, for example, create out of an e-commerce data set. And most of these are not going to be unfamiliar. So for example, you could get the total payments per customer per day of joining. You could just get the total payments per day. And you can see that we're essentially really leaning on the power of Spark to essentially help define these transformations. Now, these are just defined. Later on, we'll apply them, and then they'll be materialized and created. But yeah, okay, so I showed you a SQL example. Hey, if you are someone who loves data frames, first off, bless you. And I'm more of a SQL gal anyway, but if you really love your data frames, if you came from that pandas background, you can do it. And notice, I want to call it here too, right? Notice that essentially, once again, you can create your variants. Now, technically you could kind of leave this off and it would just default to default. But what this also means is that whenever you grab a data set or a feature, by specifying it, you're not going to get some random one that you don't understand, right? And once again, this goes back to, we can also deal with unstructured data like text. It really depends on your underlying provider. For example, if it's a provider that supports high reads and writes, you'll be able to access that power through the feature form client in UI. So here we just basically said, look, just give us like the order reviews, right? Now, the part that was really cool that I started getting into was transformation DAGs. I know all of us love DAGs. We all love Airflow. This is not Airflow, but what you can do is you can daisy chain transformations. Now, some people love writing really, really big queries. I know I do. And some people like to, create a more modular query, right? You can test it. You can add additional information. You can add the variants. So you can do that too. And that's what you're seeing here, which is we created a base, like calculate the first month and the month 1 and month 6 of a customer becoming a customer. And the idea is to get that spend. And we're actually going to use this to like train a model, like down way below the fold, right? Because essentially what we're going to say is, hey, can we predict or can we apply a regression model to figure out what the 6-month spend is going to be from the month 1 spend? So we've done that. And this is now the part where we start getting into, I think, the territory that most data scientists are familiar with, right? Which is features and labels. And then we're going to slam them into a training data set. Okay, so your first step is going to be defining your entities or registering them. You can think of this as like a primary key. You can also think of it as the entity or the object that you're studying that will then link the features and labels. And we'll see this in the feature form UI. And in this case, for example, most of the transformations that we've created have been on around orders. They've been around customers, and they've even been around more like time series. what was the customer revenue per day? Once we've gone ahead and registered those entities, we're then going to start registering the features and labels. And we're going to start linking them. And once again, folks, feel free to drop questions at any point in time. I talk really fast when I get excited, and I always love working with feature form stuff and creating new things. Okay, so features and labels. So we create a ton of transformations, right? We create daily revenue. We created a concatenation of the review text. Say, for example, maybe you want to use it in a sentiment analysis model. You could do that. And then we're going to add the spend columns. Now, before I move on, let me just quickly kind of, centralize you on a couple core pieces. For example, the entity key or object. We're saying, hey, we want to link these features and labels to a customer. Then we provide the entity column. Now, the thing that's really nice, I'm going to show you later, is if you're thinking about, okay, how do I fetch a feature for inference, right? How do I serve it? Well, essentially, you can grab features through calling the key value, in this case, like the customer unique ID. We define the Inference Store. In this case, we're using Redis Enterprise. And here we're going to define all these features. And what you're going to see is all this information will show up in the UI. So let me go ahead and run this real quick. You can define multiple features, and you can also define labels. Oh, I thank you, anonymous attendee. I appreciate that. Okay, so we defined our features and labels, and folks, we're almost there. Once again, a lot of this, honestly, if I'm not talking, it actually goes by within 5 minutes. Although, of course, I know all of us love, fooling around with feature engineering, so maybe that takes longer. Okay, so what have we done here? Well, I mentioned, right, that we were going to essentially train a model like at the end. So we registered 2 training sets. The first one is what we're just going to call the customer LTV training set. And like I mentioned, we're going to try to predict the month 6 value from the month 1 value. The second training set I mentioned is the sentiment prediction. And here, hypothetically, we're not going to train the model on this, but you could, for example, maybe apply like a Hugging Face model if you want to. And let's say, for example, the feature is like a paragraph of a review paragraph that someone left based off their purchase. And let's say, for example, you want to be able to predict the review score they're going to leave. Maybe there's other things you want to understand, right? So you can do all this through registering the training set. And very quickly, just for people who are curious more about how all these things are linked together, for the technical under the hood details, definitely feel free to go to our feature form docs. If you Google search, you can look it up. We'll also post a link if you're interested. But this shows you essentially how all this is linked together. And really, you're going to see the power of this in like the UI. So let me just quickly say, okay, let me just re-summarize. What do we do? Going from left to right, we defined or registered our infrastructure provider. We defined our data sources. We create transformations. We then said, hey, let's just register, let's create features and labels and let's define them. Let's start linking them. And then let's create these training sets where we pull together these features and labels. So all this definitive, declarative stuff that we did, it hasn't yet been created or materialized yet. This is what's going to happen when we hit .apply. You can think of it very, very similarly to Terraform apply or Vector apply, where now it's starting to create everything. It's creating all the different sources, the entities, the labels, and we're going to be able to see that in the UI. So this thing that was empty that I showed you earlier, let me also just refresh it. Okay, so you're a data scientist. It's your first day on a new team. If you're at company A, you would see a mess of notebooks. You'd see a lot of tables. Documentation would be very questionable, and you wouldn't know where to go. Let's see if that's the case here. So first thing, let's check out. is we have our providers. So you know where your data is coming from. Actually, if I click, let me just actually go here. Okay, so providers, sources. Let's say, for example, you're a data scientist, you're starting your onboarding, and your action item is to go in and understand what data that you have, right? So all these transformations that we created, all these features are now easily available. You can see all this information that we had. Why don't we go ahead and click in? So we did that. Okay, so we have this ORS source. Let me also go to calculate month 16. Oh, look at that. So we had this transformation. Some of you might recall this. Let's just go here. Okay, so we create this month 1, month 6 date transformation. We define this query. And all this information that, that we put in is now available. You can see the query itself. You can see the features that were created as a result of that transformation. Let's see. Let's click in month 1, month 6. And you get all this information on the throughput and latency. Now let's try to find one that has a training set. Okay, so we mentioned, right, that we create a data set for sentiment prediction. Here's the features. Let's take a look at the customer LTV one that we're going to use. Okay, so here's the customer LTV training that I'm just going to show you in a hot second. We have the data set here. We have the month 1 value here. Look at that. Let's say, for example, you want to understand in order to support governance and user access initiatives. Let's say, for example, you want to trace the lineage of what features are being used where. And you could do that pretty easily. And same with if we go here. You could go to the training set and you can see, what features are being used in what training sets. I could kind of click through more. You can see the objects and unused, but I think y'all's get the picture, right? And if you can imagine the data sets or the features being expanded by 10x, 100x, I know it would have been great to have this when I was working as a data scientist, instead of just trying to struggle through Confluence pages and, Slack chat messages. Okay, so we've materialized it. We've seen that, look, the data is available, it's there. Now let's actually start fetching and look at that. So what we did was we essentially all this, the data, the transformations, the features and labels that are stored on Azure and Redis, we can access the power of those providers through the feature form client the UI. So in this case, I basically said, hey, give me that sentiment prediction data set. I want the default version. And just quickly, give me some examples. We can see that right here. Okay, what about actually training it? Well, so we fetched the customer LTV training set. We said, hey, we want to shuffle it, repeat it. We want to batch it. Now let's just quickly train the model. So just random forest regression model. I know everyone here can do something way fancier, and people usually do. So what we did was we essentially got the features and labels. We fit the regression model, and then we then predicted it. So you see that here. And you can see that the call from the serving client was, it was pretty simple, right? I think most people can do this. I know I could have done this 5 years ago. Okay. Now the question everyone has though is serving features for inference. So what we can do also with the feature form UI I mentioned is access the power of Redis, but through the feature form UI. So what we basically did here was said, hey, let's just grab the month 1 values for customers with these IDs. And we were able to get that. Obviously, toy sample, but if we expand it to a very, very large data set, Like, how cool would that be? Did everyone stick around? Yeah, wasn't too much info. I know it's a lot of info. But folks, feel free once again, you know, like, let us know what you think. Like, drop in questions. I think we're all good to take a break from hearing my voice.
There's a few questions on LinkedIn I thought I'd answer real quick. One of them is, do we support versioning? And that variant that you showed before kind of counts as is the feature versioning. We have versioning for all the resources. So yeah, the variant's on the top right. So that's versioning. How do we compare to our feature stores? We have a blog post, which I'll include in the email that goes deeper into it. I know we don't have a ton of time, so I don't want to go super deep into it. But the idea is that in our world, we're orchestrating existing infrastructure, very lightweight, trying to allow you to use heterogeneous infrastructure, pick and choose the right platform for you. Let us just be the framework and the API that you use. And also, we don't own the data. The data doesn't go into feature form. We're orchestrating the data where it is. And finally, we actually do the transformation. That's a big piece. It's like the transformation logic is the feature in our world, where a lot of feature stores just do feature storage after the feature's been created, which in my experience doesn't solve a lot of the problem. Could you make me host real quick, Mikiko?
Yep. Let me just do that real quick.
So once again, y'all, I know we're coming up on time. If you have any questions, feel free to throw them in chat. I just saw that it's more sunny now. I'm all lit up. So yeah, feel free to throw any questions in chat. I'll use the last minute just to show it's an open source project. You can like check out the open source here. So there's a question which is, does feature form support feature privacy like anonymization, differential privacy? How does feature store compare to things like Feast and Feather? So the governance, access control, all that stuff is first class in feature form, but it's only in our enterprise version. So feel free to reach out. We're happy to give a demo on that. It's not an open source, but we do support it. How do we compare to feature stores like Feast or LinkedIn's Feather? So Feast is not really built for transformation piece. It's more just a feature storage. So a lot of what we do is actually orchestrating transformations across Spark, storing in Redis, all that stuff. Feast doesn't do that. It's just kind of a different design and architecture. We have a blog post, which I'll include in the question. You can Google feature store architectures. The first blog post is our thing, and you can read more there. LinkedIn Feather does do the transformation piece, but it's entirely tied to specific infrastructure providers. Like if you're happy to use those exact providers, but all your data in Feather only be in Azure, then it can work for you. But in most cases, we see, you kind of want that more general purpose usability thing. The other thing is that there's a company behind this. It's our goal to make this as successful as possible. It's not just an open source internal tool. But yeah, happy to share more there. Like I said, it's open source. Feel free to check it out. Someone asked about privacy use cases. Here's a kind of a little sense of like the policies we can provide. So you kind of get a feel for it. You can do things like say, hey, features hang on production until legal checks off on them. And even for a single data scientist, you can kind of create features, organize yourself, have that one umbrella across local experimentation and production. Yeah. Thank you all for coming. Feel free to check out the open source project. Thanks, Sam and Mikiko, for joining me today. And look forward to seeing you all soon. We'll send an email that will have some follow-up content about everything we talked about today. Great. Is there other Q&A? 3D views, thank you. We have a great designer who will be very happy to hear that. Awesome, y'all. Thank you.